have improved. Here they are. 1. Waist circumference was reduced over time. 2. Whole body lean mass was increased over time. 3. Appendicular lean mass was increased over time. So that's lean mass in the arms and legs specifically. So the quick and dirty interpretation is that lifting weights may have improved body composition by reducing waist size, yet increasing lean mass, of which muscle is a component. But what's striking here is that there were no differences between age groups. So people 15 to 20 years older and in their late 80s and 90s still experience these effects. Now, you could argue they didn't have enough people in the study to tease out a difference, and that's actually entirely fair. But as it stands, the statistics indicate no difference between groups. Pretty neat, but we needn't stop there. 2 more things that I'd like to show you. 1, quadricep size. That's a part of the leg. Here we're looking at the thickness, more accurately put, the cross-sectional area of the quadricep. The white bars are the 60s and 70s individuals, and the dark bars are the 85 plus. The individual dots are the individual datum from each person so that you can see the overall spread of the data. The first thing that you'll notice is that the younger individuals, 60s and 70s, have a larger starting muscle compared to the white before and the dark before bar graph there. This falls in line with what age that we lose muscle. However, what you'll also notice is that both groups improved over time, and that's why it's statistically significant for a time effect. Okay, I lied. I'm going to show you 3 things, not 2. In relative terms, we can see that both groups improved. This is a graph of the overall percentage improvement. But not only did they improved the same amount. Think about that for a moment. People in their 90s are seeing muscle growth similar to people 15 to 20 years younger than them. How freaking cool is that? Okay, last one, and then I'll wrap it up with some takeaways for you. Muscle size is wonderful, but elderly folks usually care more about muscle function and how well that one's muscle can serve them. So let's look at some of the strength data, and we have the same designations as before, so I won't repeat them. Again, strength starts off lower in the 90-year-olds, but again, strength improved in both groups over time. Actually, to give you a bit more of a grasp on this, at the end of the 12 weeks, the 90-year-old group had improved their leg strength by 35 kilograms, which was equivalent to the younger group after 6 weeks of training. I imagine some 90-year-olds getting off the exercise machine, flexing and yelling, "You want some?" and then kissing their bicep and glaring into the mirror. However it actually went, these numbers are impressive. Okay, so here's the deal. Resistance training definitely improves muscle size and strength when looking at lower body and upper body across all age groups, including 90-year-olds and beyond. I didn't report the upper body, but it improved for both groups too. However, spinal muscle size did not improve appreciably, but that may not matter because their spinal muscle strength likely improved. So the spinal benefit is likely also present at all age groups. Additionally, the participants had some mild improvements in body composition as indicated by improved waist size. I don't think the effects were dramatic because fat mass was largely unchanged, but that also isn't a massive surprise considering that nutrition was about the same. So the takeaway is that if you are in your 80s and 90s and beyond, your body is still capable of recovering muscle size and strength, potentially reversing some of the mechanisms that we discussed earlier. If you want the training plan detailed for you, check out the Physionic Insiders, and if you're interested in learning more on muscle growth through some of my other content, check out